by using this P, okay, and also this del in terms of this double Z derivative. So first, we do the dP over dz. dP over dz is simple. We derive this terms. So this is products of two functions. So dP over dz equals to d gamma, okay, over dz multiplied with this function. And then after this, we fix the gamma and then we derive this term. If we derive this term, we have I, there's I in front here, which is a constant. And then we derive the argument of the exponent. We have the d phi over dz plus k. Kz, you derive respect to z, you have just the constant k left over. Okay, so this is a factor that you have to multiply. And then you multiply with the exponent itself. Remember, if you take the derivative of exponent, the exponent always there. So this is the result. You take the first z derivative of this. Okay, you have two terms. So if you take the second step of time z derivative, so this result, you d over dz again. So this term will give you two terms. So first you fix this one, you have the d2 gamma over dz squared, right? You fix this one. And the second, you fix the d over the gamma over dz. You differentiate this, then you get I and this factor, and the exponent is m. And for this term, if you derive, you get three terms. First, because here are three functions of z, this, and this. So first, you fix these two, you derive this. So you have this. The I, you must not forgotten about this. So all these are very tedious. You must be very careful. And after this, you fix the gamma. So the I gamma here. You take the derivative of this factor. So constant disappear. You have d2 phi over dz squared. Okay, of course, this is constant. Okay, the second step here, you fix this first function constant, third function constant. The third one, you fix this and this constant. So if you derive this, you get this. You get I d phi over dz plus k and this exponent vector. So that's why you have square of this term. Okay. Sometimes if you confused, you just take out a paper and write it down, so you can see why you have so many terms. So d2p over dz squared, you have this 1, 2, 3, 4, and 5 terms. Okay, the blue terms here are the same. So I collect here, become this term, and the rest have no change. Okay, so the rest has no change. And after this, you apply the slowly varying envelope approximation. Okay, so this is the approximation, SVEA. So SVEA means that you delete all the terms with the second order derivative, whether the square lambda or the square pi or the lambda over dz square or this or products of these. Once you see the dz square, then you delete the terms. So by right, we should have 4 terms. But after applying the SVEA, this term delete. And you look at this term, there are 2 terms. So the term will carry the product of this and this, delete also. This term will have this term inside has this. we delete also. And this term, we have the d5 over dz squared. So that this term, when you expand, you get 3 terms. But the d5 over dz, that term square, you also cancel. So this term disappear. This term has only one term, which is this one. This term cancel. This term you have 2 terms, which is this, 2 terms. Because when you expand this, you have 3 terms. You retain these 2 terms only. So after this, I expand this bracket, so I have these 2 terms. Okay. Are you still with me?
Yes, doctor.
You can understand.
Yeah.
It's very tedious, so you have to be very careful.
Yeah.
The d2p over dz squared, then I have, after the SVEA, I have these 3 terms. And after this, do the conjugate, the p star is the same thing, but there are sign change. So after this, you can work it out. And the result should be the same, except that whenever you see the I, you change the sign. Positive become minus. This is the real one, nothing changed. But exponent I become exponent minus I. Here it doesn't change, but the exponent I become exponent minus I. All right. So altogether, we have 4 results to substitute. This one, this one, this one, and this one. Okay. So here is copy paste with this assumption. According to the articles, we have these 4 derivatives, and then we substitute into this equation 2. This equation, we substitute into this equation. No. Okay, confusion. Okay, we substitute into this equation. Okay, let me make it. What color you want? Blue. We substitute all the p and its derivative into here. So this is the results that combining the results in the article and the wave equation. We have this d2p star and so on. You might want to ask why we don't delete the d2p dz squared directly here. Cannot. Cannot. Okay. You must work it out in the full form of p. So the full form of p is like this. Okay. I mean the full form of z dependence of p is like this. You work it out, you substitute into this